for us right now, it's really just an equation where for every x we get one y back. So it's just a notation to get used to. So this would be a function, right? F of x equals 2x plus 3. So y equals 2x plus 3. This is a special equation because for every x I put in, I get one y value, so we call it a function. And the function's name is f. Okay? And so this tells you how to express it in terms of x. It would be 2 times x plus 3.
Is that what function notation is then?
Function notation is, yeah, the f of x.
Okay. That was better asked, but that was, is that?
So what kind of questions do you have with Cooper? I'm not sure.
So we're going to know the relations too?
What's that?
Relations?
Relation, well, the relation is a set of ordered pairs, right? So that's all you need to know really about that.
Oh, okay.
Oh.
And so a function is a special relation where for every x there's one y.
All right.
I have a question for Gary. For the one where it's like you remain in range and you draw that line to see what connect. How do you know if like what makes these two go to that one?
To that one? Oh, nothing on those. I just made it.
Oh.
So that's just made up.
Okay.
There's no rhyme or reason. I just pick some numbers. Said what these connect.
So,
Okay, so normally it would be something like this, right? You might see a pattern, right? Like say I had 0, 1, 2, 3, but over here I had 0, 1, 4, 9. And this was the domain and this was the range. And so they connected like this. And once the correspondence here, what's my function? It's going to be what's sending these over here? You can tell. That would be this.
X squared, yeah.
X squared.
Yeah, so, but if like the domain would equal 2 of the, or if like x equaled 2 y's, it would not be a function.
Yeah, so if
If like 2 went to 4 and 9.
yeah, so if this went to 2, yeah, then that would not be a function.
Okay.
But if it was the other way around, it would
It's okay.
Yeah.
Okay.
So the idea is that if you know y, then you should be able to find,
It's corresponding.
if you,
Yeah, sure.
so if I know x, I'll know y.
Okay. Yeah, so you should be able to find the corresponding.
So it's like that one we did with the schedule, time of day. If I know what time of day it is, then I know where you are.
Yeah.
Okay. So if you were, could be at 2 places at once, then
It wouldn't be.
it's not gonna help.
Yeah.
Okay.
So,
Do you have a certain question about the functions?
I just have work here, like, I did these problems and now look back and I don't know how to do it. Like the domain, the.
Domain?
Like, I don't know, I did that, I don't know how.
And then you gotta go back over so it stays in there,
Yeah.
otherwise, that'll be test day, right? Okay, so when you started off, we said the domain was just the x values, but when we got to equations, it gets a little bit different. So the domain for like an equation written would be the set of x values such that f of x is a real number. So if I can put it in the function and get a real number, then x is in the domain. Okay, so there are different types of domain. This is just a very generic one, right? So like on this one, what values of x can I put into this function? Oh, it's,
Put in two.
I can put, what'd you say?
Two.
Okay, you can put in 2, you can put in anything else?
Anything greater than, one?
Can I put in negative 500?
Yeah.
Negative 50 million?
Yeah.
Square root of 3?
Yeah.
Sure.
Oh,
I can put any in.
As long as it doesn't have like negative.
Because I don't, because
back.
all I have to do is make sure that this value exists, right? And I can square any number I want to, I can multiply any number by 3, those are not problems.
So what's
There's no
one-
issue.
what
So the
would-
domain on this one is
All
All the
all
numbers.
real numbers. Okay, so right now, remember what's the issues that can come up. Okay, because later on we'll have more, but
Like
right now it's
division
just division by
by
0.
And
Even.
square root even.
Yeah, the roots of, even roots of negative numbers. So like the 4th root of negative 1, I can't do that. Okay,
So if it's like a fraction, it's like
well,
the
It
square
has-
root of 3
that might be a
minus
problem,
x
right?
over 5. You don't have to worry about the 5.
Would you say square root of what?
Yeah, this is what happens. 6 over absolute value of x plus 1.
So I'd say f of x equals,
6 over the absolute value of x. Plus this. Plus 4.
oh, that outside, plus 1, like that?
Plus 4.
4. Okay, so what can go wrong with this one then? I'm not taking any roots, so that's out.
So with that, like you're just looking at the x, like you don't have to worry about the 6 and the 4.
Well, I want to make sure that, well, I'm looking at the top, right? The top is 6, it'll always be 6. Right?
Mhm.
What about the bottom? The whole bottom is the absolute value of x plus 4, right?
So
And so I have to make sure that this is what?
doesn't equal
Greater than
6.
0.
It has to be, I want to find out when will this be 0, right? I can divide by a negative number, but I can't divide by 0. That's the problem, okay? That's the potential problem,
Mhm.
division by 0. So I want to know when will this ever be 0? So if we try to solve this, we've worked on these before, right? Will the absolute value of x ever equal negative 4? No. No.
Sure.
So there's no solution to this. So the bottom, will the bottom ever be 0? No. So for this one, then my domain is all real numbers. Yeah. Anything I put in there will work. Okay. Now if I had this, 1 over x squared minus x minus 6, okay, it'll be a little different. What's the domain for this one? And you're gonna write it in interval notation, okay? So see if you can figure that one
I don't know how to do that.
out. Hmm?
I don't know how to do that.
Sure you did.
Yeah, I'm with her.
Okay, so remember what the domain is. Set of all the x values such that f of x is a real number.
Okay.
What's gonna keep this from being a real number? And what would happen? Just tell me what would happen.
It would equal 0.
No?
Or,
It can equal 0, that's fine.
okay.
What's the thing that can't be allowed?
Divided by divide.
Divide by 0. We can't divide
Yeah.
by 0.
Division by 0.
So how are you gonna figure out what values of x will make this a 0 at the bottom?
Okay.
Or we just set that equal to 0. Okay, now we have a reason to do it.
So if
Set it equal to 0 and just solve it.
minus x.
So what do we get when we solve this? two solutions, x equals 3, or x equals -2. So those would cause a problem, right? If I put 3 in here, see what would happen. I get 1 over 3 squared minus 3 minus 6, well, that's 1 over 0. And that's undefined, right? It's not a real number, so that causes a problem. F of x has to be a real number for x to be in the domain. And so
We would write,
that's why we have to get rid of it.
so we,
what's my domain?
negative infinity to -2,
Uh-huh.
and then,
Mhm.
3 to infinity.
Okay, and don't forget the ones in the middle.
yeah, isn't there -2 to negative, yeah, to 3.
Okay, so how do you know that one's negative infinity to infinity?
This one?
Yeah, like how do you know that?
We know that because, is there any division going on? No, because this,
Oh, that one's divided.
this is a different one. Sorry. Are you talking about this one?
No, I was looking at it, but I forgot. So, like, if it's square root of 3 minus x over 5, you don't mess with the 5. You just do it with the x.
5's in the denominator?
Yeah.
Yeah, because 5 will never be 0, so that's not an issue. The issue is taking the square roots of negative numbers. So that's what's restricting your domain.
So then you just set that greater than or equal to 0.
Let's see, which one is that?
It's like basically all.
Number 103?
It's like basically all of 95 and 108.
So this one? So what could go wrong on this one? Well, there's only two things we're looking for right now. Division by 0, is that gonna happen? No,
No.
we're looking for 5. Square root of or an even root of a negative number? Well, possibly, right, because I'm taking an even root. Right, this is a square root, that's an even index. So what I have to say then is 3 minus x has to always be 1. Greater than or equal to 0.
Okay.
And so 3 is equal to x, and we just spin it around. So x has to be less than or equal to 3.
So that'd be negative infinity to 3.
Yes.
Would 3 be in the bracket or parentheses?
Brackets. That's the equal sign.
Okay.
I'm confused on unions and intersections.
Oh, okay, well, it's not a huge deal, but, so the U, looks like a U, so
Yeah.
that's the union. The upside down one would be the intersection.
Yeah.
So the union just means that this, or this, or this. Or intersection means and. This is gonna be here and in this one.
So the
Okay, this is the overlap. Okay, like if you have a blue Ford, okay? It's gotta be a Ford and it's gonna be blue. So it's got both qualities. If I said the cars would be, if I want you to go out in the parking lot and count all the blue cars or a Ford, then you would count all the Fords and you count all the blues. Okay, there'd be some overlap,
Mhm.
okay, but that's the or thing, okay, this or
Okay.
this. Okay?
So the domain that's up there, is that, like, what's that basically saying? Is it saying it can't be those?
It says, no, this is the domain, so this is, these are the values it can be. X can be in all those numbers. It can't be -2 and it can't be 3.
So on the left where it says negative infinity to -2, that's like the cutoff. We go from negative infinity to -2. Like it can't be either -2 or 3.
Yeah, so I have to skip -2 and then anything between -2 and 3 will work. Right, 1.5, 1.87382, 150, all those numbers.
But anything greater than 3 will.
And anything greater than 3 will work, but 3 won't, because it causes division by 0. So the division by 0 is usually going to be in discrete numbers, right? So here we had -2 and 3. But over here, right, there's a bunch of numbers that will cause